So we just finished talking a little bit about input transformers and nickel and some of the details associated to how they work and how we use them. And now I'd like to talk about output transformers. The construction of the output transformer is quite different. I'm holding here the EI laminations. Actually, these are all kind of bonded together because they've actually been, they've gone through the cooking process. So it's a different type of material. It's usually a silicone, heavy silicone-based steel, a lamination. Also important to treat it the same way we do with the nickel laminations. But it's a completely different animal. Here's where, as a designer, you can use different types of construction techniques to control the behavior of the transformer in terms of how it treats the audio signal. In our case, we wind our own bobbins, and we have a very specific way we do that. We use a 5-layer topology, which is very similar to some of the things that you would see in UK transformers in the 60s. I really like that sort of sound. There's another term that you'll hear about in transformer construction, which is the transformer gapped or is the transformer ungapped? By saying it's ungapped means that the lamination is in complete contact, like this, metal to metal. If it's gapped, we actually put a layer of material between this lamination, the E, and the I. And that gapping is responsible for generating certain harmonics at the output stage of the output transformer. And you balance that out with the electronic signal. We actually run a tiny bit of DC into so direct current, which is kind of unusual. We put it on top of the AC audio signal. And this actually is kind of like pulling it's like charging the transformer. And you need to bias it, etc. But you get a really sweet sound out of it, and you almost get this, if you do the output stage correctly, you can get sort of this emulated tube sound out of it by controlling the even harmonics. There's different flavors of output transformers, and the way you drive those transformers, basically the output stage, really defines that flavor, that color that you can get. We use an awful lot of Carnhills. The big what we call a 75.75. 0.75 refers to the size of this little core. This is a 5/8, and the bigger transformer is a 3/4 inch bobbin size. The bigger the transformer, it doesn't necessarily change the vocal characteristics, but the larger core allows for lower distortion at really low frequencies. But this is the traditional Carnhill transformer that we use inside our XMod product. It's a lovely sounding transformer. People really, really like it. When we decided to make our own transformers, we went for a smaller core. And the smaller core basically gives you a slightly different set of colors in the mid-band range and in the vocal range. And it's almost personal preference. So when you use a normal 7603, you're kind of getting all of the color that we like, all of the flavor that we like. But again, this is the area between the design of the output stage, Class A, Class AB, whether you use an IC to drive it, really starts determining the overall character of your product.